Okay, I'm going to talk about atomic structure and ions. So first, let's start with atomic structure. So we know that Dalton proposed that the smallest unit of an element is an atom, and that was some indivisible particle. Okay, but then there were further studies that told us that those atoms then were made up of smaller particles. Okay, the subatomic particles, protons, neutrons, and electrons. Okay, um, and based on those experiments that helped to discover that there are smaller pieces, those experiments helped lead to now a new model of the atom. Okay, and so, or it went through different proposed models, and one of the important ones was the Thomson model, the plum pudding model. But we know that that's not a good model. Okay, so now what we're going to look at is the model that's actually accepted today. Okay, this is the model we still accept, that this is what an atom, or how an atom is built. Okay, what makes up an atom, I guess is a better way to say it. Um, so for the nuclear model, in an atom, we have kind of, you could think of this two regions, I guess. You have this outer region, and then you have the nucleus. So that's the inside. Um, and in these two regions of an atom, the outer region that I'm talking about, that's actually mostly empty space. Okay. Um, but the nucleus, which is in the center of our atom, is very dense. It contains most of an atom's mass. Okay, so it's a very compact region. So the subatomic particles that are there are tightly packed, whereas the subatomic particles that are in the outer region are spaced out greatly. And specifically, the subatomic particles we're talking about are electrons, which are in that outer region. So the electrons are on the outside, and they're spaced out. So there's a lot of empty space, and then there's electrons kind of distributed out in that space. And so it's kind of similar to a gas. If you have a gas sample, you have all this empty space and then gas particles throughout. And then we have the nucleus, that dense portion in the center that contains protons and neutrons, and those are packed very tightly together. And on here I have indicated that electrons we designate as E minus, protons as P plus, neutrons as N naught. And so that's just to kind of shorthand instead of writing them out. And they also give an indication of the charge on those things. So electrons are negative particles, so the negative particles are on the outside. So that's kind of the most accessible part of an atom, whereas the positive particles are in this dense center in the nucleus, and so are the neutral particles, the neutrons. Those are also in the nucleus. And remember, I said that the dense region, that nucleus, contains most of the atom's mass. And so really your protons and neutrons have very high masses compared to electrons. So electrons take up most of the space, but they have very little mass. Whereas protons and neutrons have very large mass relative to electrons, but they take up very little space within that region of the atom. So here's kind of a picture, a representation of what the scale of, the nucleus of an atom to the electron space, that outer region, would be. So if you had a gold atom, the approximate size of a gold atom is 288 picometers. Okay. And then they have the zoomed in nucleus there. And the nucleus of a gold atom is only about 0.01 picometers. And so it's very small relative to the total size of that atom. Okay, really, the electrons or that outer region is about 99.99% of an atom's space, okay, or more. It just depends on which atom you're talking about, on what the ratio of that space occupied is, but it's always very high. It's always going to be 99+% is empty space, essentially. And so that's kind of your basic structure of an atom, okay? Now, some other specifics about electrons, protons, and neutrons are given in this table. It's not something typically you have to memorize. So we do have the mass of electron and proton and neutron measured relatively accurately. You can even get measurements of their masses to more decimal places if you go look at other resources. But what you should notice here is notice that these masses, they're given in grams, okay, and they're tiny, right? 10 to the negative 28th, 10 to the negative 24th. So that's very small, okay? But that should make sense because atoms are so tiny we can't see them with our eyes. And so if we're talking about things that make up atoms, so they're even smaller than atoms, then yes, they're very tiny. So their masses are very small. But you should also notice with those masses that the mass of an electron is significantly smaller than for a proton and a neutron. The mass of a proton and the mass of a neutron are pretty similar, okay? And they're much larger. They're about 2,000 times more massive than an electron. And so that's why we say they take up the majority of an atom's mass, okay? So if you have an atom and you were to take away an electron, the mass wouldn't change very much. It would be negligible relative to the mass that we're looking at. Whereas if you were to take a proton or a neutron away, there would be a significant change in the mass. Okay, so that's important to realize. Now, this table also gives an actual charge in coulombs for these things. That's not something that we would usually use on just a general level. But that information's there. Those charges are quantified. You can do calculations with them. We're not going to look at that right now or even later. What's more useful on this table with respect to charge is the relative charge. When we talk about these subatomic particles, when we talk about things losing or gaining electrons, we look at relative charges. And so when we quantify the charge on an ion, we are talking about the relative charge, okay? If we're quantifying the charge of an electron is -1 and the charge of proton is +1, okay? Because they have equal charges, opposite signs. So we just talk about it on this whole number scale. Now, let's talk about the difference between atoms and ions. So an atom is something that is electrically neutral. So it has the same number of protons as electrons, which I think that's what I have next is electrically neutral here. Okay. Whereas ions are things that have a different number of protons and electrons within them. And so those things we would classify as either cations or anions, depending on which is greater. Okay, so depending on, do you have more protons or do you have more electrons? Okay, so if you have some particle and it has an equal number of protons as electrons, then it's an atom and it overall is neutral. But if you have something that has more protons than electrons or more electrons than protons, it is some sort of ion. And specifically, if we have more protons than electrons, then overall there's more positive charge. So overall that species is positive and we call it a cation. And if it has more electrons than protons, then it overall is negative and we call it an anion. And typically, most often, metals are the types of elements that tend to lose electrons and form cations, okay? Now, that's not to say you couldn't ever have a non-metal lose an electron. It just isn't very favorable, so it doesn't happen unless if you force it to, okay? Whereas non-metals generally are going to favor taking on electrons, so taking them from something else, thereby forming anions. Again, it's not to say that a metal can't take on electrons. It's just, it's not favorable and you'd have to force it, okay? Now, when I'm talking about changes in these things, I'm saying losing or gaining electrons. That's another important thing to realize. When we're dealing with atoms or molecules and doing chemical reactions, that's always going to involve electrons being lost or gained or being shared in different ways, okay? The protons and neutrons don't generally exchange in a reaction, okay? They're not affected unless if you're dealing with a nuclear reaction, okay? But if there's just some general chemical change, that all is involved with the electrons, okay? So if you have an atom and it forms a cation, the way that forms is by that atom losing electrons, okay? Whereas if you have an atom forming an anion, it does that by taking on electrons. So things don't form cations by gaining protons, okay? It just doesn't happen. Now, it could happen, I guess, in a nuclear reaction. We're not talking about nuclear chemistry right now. So just realize that when a cation or anion forms, it is because electrons or electrons are released or gained by something. Now, some examples. If you have magnesium, magnesium has 12 protons, 12 neutrons, and 12 electrons, at least the kind of a stable nucleus of magnesium, okay? Or I should say, sorry, a stable atom of magnesium, okay? The 12 protons and 12 electrons is the really important part. The neutrons can vary. So we'll talk about that later, not in this video. But the protons and electrons are equal, so it's overall neutral. So that would be a magnesium atom, okay? But if we took that neutral magnesium atom and we took away 2 electrons, so we formed this ion that has 12 protons, 12 neutrons, and 10 electrons, then overall that would have a positive 2 charge, or we write it as a 2 plus charge, okay? That would be a cation, okay, because it has a positive charge and it was formed by losing electrons, and that is going to be likely when you have a metal. And magnesium is a metal. If you look at the periodic table, it is on the left-hand side of the periodic table. So it is a metal. Another example, if we look at a non-metal, if we have a nitrogen atom, a stable nitrogen atom has 7 protons, 7 neutrons, and 7 electrons, okay? Kind of the key here is, since it has 7 protons and 7 electrons, it overall is neutral, meaning that's an atom. But if instead it had 10 electrons with those 7 protons, then that means it isn't overall neutral. It has 3 additional electrons, meaning that it's an anion. It has an overall negative 3 charge, which we write with a 3 minus next to it, okay? And so that's an anion. And that happens with a lot of different nonmetals. So metals tend to give up electrons, forming these cations, and nonmetals tend to take on extra electrons and form anions.